Look at example 8. Nonlinear system solved by substitution. X squared equals y minus 1, 4x minus y equals negative 1. So what I'm going to do here is I'm going to take the first equation, x squared equals to y minus 1, and I'm going to solve for y by adding 1 on both sides. So now I can take this second equation, or I can take this right here, and I'm going to substitute that into the second equation. So I know that y is equal to x squared plus 1, so I can substitute that in here. So I'm going to get 4x minus x squared plus 1 equals negative 1. So if we simplify, we get 4x minus x squared minus 1 equals negative 1. Add 1 on both sides. Since this is quadratic, you want to have everything on the same side. Negative 1 plus 1 is 0. And so now here I can factor out an x. So I'm going to have x is equal to 0 and 4 minus x is equal to 0. So my solution here is x is equal to 0 and x is equal to subtract 4. So we get negative x equals negative 4 and then divide by negative 1. X equals 0 and x equals 4. So now we need to back substitute. So let's look at x equals 0 first. And I'm going to plug that in to the first equation. So if x is 0, we get 0 squared equals y minus 1. So y is going to be equal to 1. So my solution here is when x is 0, then y is equal to 1. And now let's do x equals 4. Same equation. 4 squared is 16. Add the 1. So here, when x is 4, y is 17. So that's going to be our solution. And just so that we can see what the graph looks like, the first equation is x squared equals y minus 1. So that's a parabola. And then we have 4x minus y equals negative 1. And so you notice where they intersect, that's the first point we got, 0, 1. And the second point is right here, 417. Okay, so this is an example of a nonlinear solution or nonlinear equation. So let's go to example 9. So here we have a line. This is a line. And then we have a circle. And so we can use substitution method. So the first thing I'm going to do is I'm going to solve for this equation. I'm going to solve for x. So I get that x is equal to negative 2y. So now I can replace my x with negative 2y. So I'm going to go ahead and work that out over here. X minus 1 squared plus y minus 1 squared equals 5. So instead of x, I'm going to replace x with negative 2y minus 1 squared plus y minus 1 squared equals to 5. Since this is, we need to solve for y, so I'm going to simplify this further. So negative 2y minus 1 squared, I can write as 2y minus 1 times negative 2y minus 1 plus y minus 1 times y minus 1 equal to 5. Negative 2y times negative 2y is 4y squared. Negative 2y times negative 1 is positive 2y plus 2y plus 1. Y times y is y squared minus y plus 1. Let's gather like terms. 4y squared and y squared is 5y squared. 2y plus 2y is 4y. Minus y is 3y. Minus y is 2y. Then we have 1 plus 1 is 2. Subtract the 5 on both sides since this is quadratic. And so we're left with this quadratic equation. 5y squared plus 2y minus 3. So you have choices. You can use the quadratic formula or you can see if this is factorable. I normally check to see if it's factorable first. And so here we would have 3 times 1 is 3. I need this to be negative, so one sign would be negative, one would be positive. The 2 has to be positive, so the bigger value should be positive. 5y times 1 is bigger than 3y. And so I can solve for set each factor equal to 0. So y is equal to negative 1. And y is equal to 3/5. So now we have to back substitute. So let's check y equals negative 1 first. I'm going to use the first equation, this one here that I rewrote. So if y is negative 1, then x is going to be 2. So when x is 2, y is negative 1. And then let's check x is 3/5. So we get negative 6/5. So x is negative 6/5 when y is equal to 3/5. So I just wrote on this side. So this is my solution. So now, just in curiosity, let's look at our graphs. So we have the first one, x equals negative 2y. And let me just recenter this. And then our circle is x minus 1 squared plus y minus 1 squared equal to 5. So where the lines intersect, we have negative 1.2 and 0.6. And you have 2 and negative 1. So these are 2 answers that we got when we worked it out on our paper. Okay, let's try example 10. So here we have 2 circles. So the best method to use here would be elimination addition. And so we need to pick a variable that we can cancel. So I'm going to choose the y's here. So I'm going to multiply this by 3. So that's going to give me 9x squared plus 6y squared is equal to 35 times 3 would be 59,105. Okay. And then the second one, I'm going to multiply by negative 2. So this would be negative 8x squared minus 6y squared is equal to negative 96. So if we add this, we get x squared, this would be 0, is equal to 9. Take the square root, so x is equal to plus or minus 3. So now we need to back substitute to solve for y. So I'm going to do that up here. So we can pick any equation. I'm going to pick the first one. 3x squared plus 2y squared equals 35. And I'm going to let x equals 3 first. So 3 times 3 squared plus 2y squared equals 35. 3 squared is 9 times 3 is 27. Plus 2y squared equals 35. Subtract 27. So we get 2y squared is equal to 8 divided by 2. Y squared is equal to 4. Take the square root. So we get that y is equal to plus or minus 2. So when x is 3, we get y is equal to positive 2. But we also get that y is equal to negative 2. So now let's check for x equals negative 3. So I'm going to use the same equation. And notice what's going to happen. Negative 3 squared is 9 times 3 is 27. And so if you notice, that's the same as this. So my answer here will still be y equals plus or minus 2. So when x is negative 3, we get positive 2 and negative 2. So this is my solution. Okay, so the graph will look like this. So we have the first equation, 3x squared plus 2y squared equals 35. Second one is 4x squared plus 3y squared equals 48. And so we can zoom in a little bit. So here we have negative 3 and positive 2, 3 and positive 2, or this is negative 3, positive 2, 3 and positive 2. And then we also have negative 3, negative 2, and 3 and negative 2. Here it's pretty close, but it's not quite intersecting. So those are our solutions for this problem.